Ignition sequence starts.
Good morning, and welcome to a look at the activity inside the International Space Station Flight Control Room at NASA's Johnson Space Center, the home of 24/7 monitoring of all space station systems. The Expedition 65 crew members are finishing up a work week that was focused on scientific research. The 7 astronauts and cosmonauts spent most of the week supporting groundbreaking experiments at facilities throughout the station's laboratory modules.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Katherine Clayton. This week we lead with science and learn how gravity impacts our immune system. The Celestial Immunity Investigation evaluates the effects of gravity on functional immune response. NASA astronauts Mark Vande Hei and Megan MacArthur performed activities to prepare for the investigation's 3-week run. The investigation uses lymphocytes, a type of white blood cell, and expands the length of observation, analyzes a wider array of activated immune pathways, and examines the role of age by evaluating cells from elderly and younger donors. On Earth, gravity, convection, and buoyancy interfere with cell behavior in laboratory-based studies, but microgravity eliminates these factors. Results could support development of new vaccines and drugs to prevent and treat existing and emerging human diseases. Just ahead of the Atlantic hurricane season, the ISS crew met with Weather Nation TV to discuss Earth observations from the space station.
Meredith, on my last flight, I got to see a hurricane. Of course, those are devastating on the ground. Up here, it's hard to believe that something that looks that beautiful is causing that much damage.
You can look straight down into the eye of the storm, which is hugely impressive. You see those massive walls, and then you look straight down from the space station with our biggest telephoto lens. That's one of the most impressive pictures I've ever seen taken from the space station.
NASA is abuzz about news on 2 exciting missions. The Boeing Starliner's Uncrewed Orbital Flight Test 2 announced a new target launch date for Friday, July 30th. This uncrewed flight test to the International Space Station is a key milestone towards the first Starliner crewed mission expected later this year. This week, NASA announced an agreement with Axiom Space for the first private astronaut mission to the space station, expected to launch January next year. This mission marks the expansion of human space exploration to non-traditional users as part of NASA's efforts to grow a low Earth orbit economy. That's Space to Ground for this week. Thanks for watching, and we'll see you next week.
Four of these astronauts, representing 3 different countries, flew on Crew 2 to the one and only International Space Station. Before launch, we got each of them to stand still for some rapid-fire questioning. And here's the straight skinny on their favorite foods, colors, and decades, their pet peeves and guilty pleasures, and who inspires them.
Tacos, cheese and dairy. I know it's cliche for a Frenchman, but it's true.
Ramen noodles.
Cookies.
Favorite color is blue.
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 Orange.
Haagen-Dazs strawberry.
Pistachio.
Mint chip.
Plain vanilla, low quality fast food ice cream.
The Princess Bride.
Favorite movie is Proxima. It's named after my first mission. It's the story of a female astronaut, European, French woman going to space. Anything with Bourne or Bond?
It's hard to say. A couple of Japanese mystery books.
Extreme ownership.
I love books, so I can't choose just one.
I don't have any. I read a lot of books, and I think if I had a favorite one, I would stop reading. But like every new one is my favorite book, and that's what I keep reading.
I like skiing.
Basketball.
Rugby.
Golf.
I don't dance.
I've been here long enough. Not falling for it.
The moonwalk. Easy, but not really. That's the single ladies choreography.
The 90s were pretty great.
That's when I fell in love, got married.
That's when I was in college and the music was really great.
Kids were born in the 90s. I had some great jobs of flying Apache helicopters and jumping out of airplanes. Every decade is the one we're in. I think things get better.
Mean drivers.
Inefficiency.
I don't have anything. Nothing bothers me.
I do have a superpower, and it's to make kids happy. Sometimes, they want a selfie or an autograph, and you make them happy, and I think that's a really cool superpower to have.
To fly.
I would have to say fly.
Flying, obviously.
Rom-coms. I never watch movies, but sometimes when I do, I end up with, feel-good, happy ending love stories.
Ice cream.
Well, chocolate, but I don't actually feel all that guilty about it.
Parent.
Being a parent,
Parent, for sure.
it's not even close.
My wife.
Friends and families.
My husband.
I'd say my partner in life. She's the funniest person in the world.
My dad.
Amanda Gorman.
I think my parents are really normal people who takes responsibilities at the local level and try to do the good things.
Coffee.
Tea.
Coffee, definitely.
Tea.
Build a sandcastle.
I think I'd hop on a rover and go cruising around all day.
Look for footprints.
Probably do backflips. I was on a parabolic flight with Mars gravity and moon gravity. I can do a double backflip in moon gravity, but I'm not quite sure on Mars, but I would try it.
I think it's Russian language, and one of my former crewmates told me, for Russian language, the first 10 years are the hardest, so I think that's pretty accurate.
I think the volume and the variety is what makes it hard, but that's also what makes it great.
Sugar.
I do. I do have a call sign, but I cannot tell you what it is and why.
Leave it there.
International Space Station science research is being used to teach humans more of what we need to know to explore out beyond Earth. For example, biomining could offer a way for crews to obtain needed materials on other planetary bodies. But microbes and rocks interact differently outside of Earth's gravity than they do here, and that might affect the output from extraterrestrial biomining. So, there's an investigation on the station right now studying how microbes grow on and how they alter planetary rocks.
The International Space Station will soon host some of the smallest miners in the universe, microbes. Microbes growing on the surface of rocks can gradually break them down and extract useful minerals and metals. This is a process called biomining. As we explore space, we are seeking to use biomining to turn rock and regolith into soil for growing plants and food. But before we can use this technique in planetary settlements, we first need to test it in space. On the space station, bioreactors will be placed inside a centrifuge where microbes will grow on rocks in microgravity and simulated Martian gravity. Investigators will examine how 3 types of microbes behave within pieces of basalt and evaluate how well the different microbes extract elements from the rocks. The findings will be compared to ground-based results. We hope to gain insights into how microbes interact with rocks in microgravity and how we might use them in our exploration of deep space.
Space station science is also focusing on the secrets of the human body. 4 years ago, astronaut Kate Rubins became the first person ever to sequence DNA in space. So recently, when she moved space station science forward again with another crucial milestone for microbiology, the research team here in Houston took a moment to recognize Rubins' spot in scientific history.
Kate, while you do that, I have a few words for you. So today marks 4 years, 4 months, 3 weeks, and 5 days since one monumental jump of paradigm-shifting spaceflight science occurred when you, for the first time, sequenced DNA beyond the bounds of Earth. Since that time, 6 of your crew members have advanced that work and demonstrated significant advancements in microbiology through culture-dependent and culture-independent identification of microbes, human diagnostics when native RNA was prepped and directly sequenced on station, and in fundamental biology when sequencing was used to assess DNA repair following cellular transformation and CRISPR-based DNA damage, all on board. And that came from the minds of a team of high school students who won Genes in Space. Your work revolutionized space science, and today marks another significant achievement with the collection, preparation, and sequencing of highly complex and multiplex samples. On behalf of the biomolecule sequencer team, aka Manan team, myself, Sarah Stahl-Rommel, Aaron Burton, and Kristen John, and the whole spaceflight science community, we thank you for continuing to push space science through your work on board and through all you do to socialize and emphasize the importance of molecular biology in space. Thank you, Kate.
Oh my gosh, you guys are going to make me cry. This is so cool. I'm just incredibly excited to see this, and I've been talking about multiplexing for years, so this is amazing that you guys have been able to do this, and it's really, really, really fun to be at the pointy end of this spear here and to get a chance to do the sequencing in space. So I'm very excited about this, and I can't wait until we're multiplexing 96 well plates and swabbing everything on the space station.
That's where we're headed next.
International Space Station science about the human body includes other experiments, like ones trying to find out more about how the human body responds when it's in a weightless environment for an extended period. One particular area of interest is the human immune system.
Your immune system in space. Presented by Science at NASA. Getting sick when you're far from home is a drag. You'd give anything to crawl into your own soft bed and sleep, but you're stuck in a cookie-cutter hotel room feeling like a sick fish out of water. Well, it could be worse. You could be an astronaut on the way to Mars, a really long way from Mom's chicken soup. Future space travelers will need to stay healthy to perform well for their own safety and for mission success. So it's important to understand how extended space travel will affect them. The immune system works unnoticed to protect the body. But even subtle changes in that all-important system may be linked to the onset of illness. Factors like radiation, microgravity, stress, and altered sleep cycles could all affect astronaut immune systems. A new NASA study entitled Functional Immune will investigate the immune system changes that occur in International Space Station, or ISS, crew members. Understanding these immune system changes may help scientists pinpoint the onset of illness and suggest monitoring strategies or treatments that can boost the immune system and prevent full-blown infections and diseases here on Earth. Functional Immune builds upon the results of several previous NASA studies of the immune system, which, according to Johns Hopkins University scientist Dr. Mark Shellhammer, tell us there is no place during spaceflight where we see stabilization of the immune system. In 2014, NASA's Integrated Immune Study showed abnormalities can occur in immune cells in ISS crew members' blood during flight. Normally, the immune system attacks and eliminates virus-infected cells. When cell activity is depressed, the immune system isn't responding to threats as it should. When cell activity heightens, the immune system reacts excessively, which can result in illness, increased allergy symptoms, and persistent rashes. ISS crews were also observed to experience reactivation of latent viruses from childhood, a finding directly related to reduced immune function. The Integrated Immune Team, working with the NASA Nutrition Laboratory, also measured the concentration of cytokines in blood plasma, the proteins that marshal the forces to an infected or injured body site to defend against invaders. The data indicated that changes can be seen in blood cytokines just as changes can be seen in cell function. Dr. Brian Cruchon of NASA's Johnson Space Center, or JSC, principal investigator of the Functional Immune Study, says, "The immune system is very complex, and several aspects of immunity remain uninvestigated during spaceflight. We now need to delve deeper into the immune system changes that happen in space, and also determine if immune changes during flight elevate clinical risks for astronauts in future deep space missions. All the factors that change immunity on the ISS will be worse on longer missions to an asteroid or to Mars. Functional Immune includes NASA scientists and external collaborators at the Johnson Space Center Radiation Lab, the University of Houston, and the State University of New York. The study will reach beyond any previous space immune study and include exciting newer tests such as transcriptomics and proteomics. These tests will happen in parallel with the assessment of immune cells in blood, stress, and virus reactivation. Christian says with the ISS, we have a unique opportunity to study very healthy people in a quasi-isolation chamber, yet experiencing all the stressors that are specific to spaceflight. Results should help clarify the influence of spaceflight-specific environmental factors on immunity and identify countermeasures to mitigate their effects. These studies could improve scientists' understanding of the immune system, making a positive impact on human health at home and while traveling both near and far. For more from the International Space Station, go to www.nasa.gov/station. For more news about spaceflight and the strange things it does to the human body, visit science.nasa.gov.
When you look up at the night sky, you notice the moon appears to change shape from night to night. Those different shapes that we see at different times of the month are called the moon's phases. Well, in this demonstrations video, NASA astronaut Anne McClain and a friend with an Earth-shaped head explain why the phases of the moon occur as they do.
Hi there. My name is Anne McClain, and I'm an astronaut who has lived and worked 250 miles above the Earth's surface on the International Space Station. Today we're going to be turning our eyes toward the moon and learning more about what causes the moon phases. But before we check out the moon phases, let's take a look at where the space station is compared to where we are on Earth and where the moon and the sun are. On Earth, you're only about 250 miles below the station. The moon, however, is located 238,855 miles on average from Earth. You could fit 30 Earths in that distance. When you think about how far away we are from you on the station versus how far away the moon is, the station is only a tiny bit closer to the moon than we are here on Earth. And that's only when the station is in orbit on the same side of Earth as the moon. So, the station is 250 miles away, the moon is 238,855 miles away, and the sun is approximately 92,900,000 miles away. That is quite the distance. Now that you know where you are relative to the station, moon, and the sun, let's talk about the moon phases. Now, when you're looking up at the moon from the Earth, you'll notice that it looks different from day to day. We call these differences the phases of the moon, and they cycle through every 30 days. Let's check out a demonstration of the moon phases here on the ground. We're going to pretend his head is Earth, letting him view the moon as you would from your home. The ball in their hand is going to represent the moon, and the light source is going to be our sun. Keep in mind that while the moon is orbiting Earth, Earth is also rotating on its axis and slowly orbiting the sun. Now, looking from our outsider perspective, we can see the moon is still whole the entire time it is orbiting around Earth, with the side facing the sun always illuminated and reflecting sunlight. Let's take a look at what he is seeing. As you can see in the photographs from Earth's view, the reflection of sunlight looks quite different from this angle, since we are only able to see parts of the reflected sunlight as the moon moves around Earth. This is what causes our moon phases, as the moon orbits around Earth every 30 days. There are names for each of the phases of the moon's 30-day cycle. When the moon looks completely dark, we're experiencing a new moon. This is the beginning of the 30-day cycle. It will move through a waxing crescent phase until it is a first quarter moon. From here, we will see a waxing gibbous until the moon appears fully illuminated. You might have heard this phase before. This is what we call a full moon. After this phase, the moon will go from a waning gibbous phase into a third quarter moon. After the third quarter moon, it will become a waning crescent until it returns to a new moon. On the space station, we see the same moon phases as we do on the Earth's surface. Since the space station is only 250 miles closer to the moon than we are here on the ground, astronauts on the station have the same perspective you have, but don't have the Earth's atmosphere in their way for photographs. Astronauts currently on the space station actually use the moon's phases to collect research that will help NASA with the Artemis program as we work to go forward to the moon with our astronauts by 2024. So, the next time you're outside, take a glance up at the moon to check out what phase it's in. Are you interested in seeing the space station fly by as well? Ask an adult to help you sign up for Spot the Station at spotthestation.nasa.gov. Thanks for learning with me today. See you next time.
In the 20-plus years of human presence on the International Space Station, many of the 244 different human beings who have been there have undergone a shift in their worldview. Apparently, looking down on the entire world can have that effect on people. Well, in fact, the effect has a name. It's called the overview effect.
We have ignition sequence start. 5, 4, 3, 2, all engines running.
My first sunrise from the Soyuz is a moment I will never forget. You couldn't wipe the smile off of my face. It was really amazing.
Experiencing the views of the Earth, it's just, so incredible. It's just almost overwhelming when you first see it.
As much as we love the pictures that we bring back, it's not the same as seeing it yourself.
There's no words to come close to the ever-changing picture that I see staring at this planet.
Those who see Earth from the International Space Station often say it provides them a new appreciation of our planet. Well, many of the pictures they take of that planet are also providing raw material for other experiments. The Avian Migration Aerial Surface Space Project takes advantage of thousands of images captured by astronauts to give people an understanding of the migrations many birds undertake across the planet.
I flew as a Canadian astronaut on the mission STS-42, Space Shuttle Discovery, back in January of 1992. Currently, my role as president of the foundation that bears my name is to conduct some research into the migratory corridor, habitats, and behaviors of certain species of migratory birds. We've been trying to utilize photography to put together a compelling reason why people need to pay attention to these very fragile organisms and their fragile environments. We think that doing it at 3 different levels, the aerial, surface, and space, will provide the different perspective. So it's as if we were down at carpet level with a magnifying glass on the surface, And then we get up and we see the patterns a little bit differently. And then we get into space and see this whole corridor, but we see different patterns that we didn't even know existed. So the space station can provide us these images so we can actually construct part of that flight, a part of that corridor of one of these species.
Growing up as a Canadian, Dr. Bundar was one of my heroes. She was the first female astronaut that we had in Canada, and I always kind of looked up to her because she was also a scientist and a physician. And there she was offering me the chance to participate in this beautiful project. And I loved because it fit with my hopes of sharing from space station my love of the environment. One of the challenges of taking photos of the Earth from space station is that we're going pretty fast. You know, we're going around the world in about an hour and a half, flying at 5 miles a second. And as you get to the cupola, get your camera ready, you're looking at previous images, satellite imagery, trying to wrap your mind around what you're trying to see. And then you look forward towards, the limb of the Earth as the Earth the scene is coming towards you. It's coming pretty fast. And you gotta identify it on the horizon as it approaches, because you have maybe just a few seconds as you're flying over that location. And then you look back and maybe you have a few more chances as you're flying away from it, but that's it. The whole thing lasts, way less than a minute. But kind of chasing the right frame is a bit of an art because you only have one chance.
To date, we have at least, I'd say, somewhere between 25,000 images provided to us from NASA.
This was one of the larger imagery projects that we've worked on. Typically, we work with researchers or scientists that are looking at a few different locations on Earth, maybe no more than 10. And this ended up being about 50 different locations on Earth that we wanted both nadir looking shots, which is a straight down looking shot, as well as Earth limb shots. We worked with various crew members over the years to take a lot of these photos, but we also reached back into our database of over 4 million astronaut photos just to see what already existed. We get excited when external groups seek out these types of imagery projects with us, especially scientific and research groups.
Space exploration really offers us an amazing perspective on our home. And I think this project is a beautiful example of how we can kind of scratch our heads, take a few steps back, look at the big picture.
It's about taking that creativity that were offered in space, combining that with the aerial shots of getting closer and closer to when they put their feet on the ground, to me is an extraordinary way of trying to bring together this emotional story of the importance of habitat protection so that these beautiful, magnificent creatures that fly the way we do in space can survive on our planet for future generations.
If you want another look at any of the stories you saw today, you can always find them on YouTube and Facebook. You'll also find lots of other great features there on a wide variety of NASA topics, so look around. Now, if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show talking to folks involved in all areas of space exploration. Today, we feature an interesting discussion involving representatives from the International Space Station partner space agencies, talking about how they came to begin this worldwide partnership and what working together for more than 20 years now has meant for each country. Go to nasa.gov/podcasts for this week's episode. In fact, all the previous episodes are there. So's the full library of all the NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.